Here is problem number 2 from Homework 8-2. Number 2 reads, a 0.75 meter long baton has a mass of 12 kilograms attached to one end and a mass of 18 kilograms attached to the other end. What is its moment of inertia when it is spun around its midpoint? Second question, where would you rotate it so that it would have the smallest moment of inertia? To solve for moment of inertia when we have point masses at the end of a baton, this is actually similar to number 1, which is already posted to YouTube. We have a baton massless with a mass of 12 kilograms on one end, 18 kilograms on the other end, and it has an overall length of 0.75 meters. To calculate moment of inertia for a point mass system, we have I equals sigma mr squared, which means we need to take the mass times the distance from the point of rotation squared. So we have m1, which was 12 kilograms, m2, which was 18 kilograms. Solving for the first moment of inertia for our first point mass, we have I equals m1r squared. m1 was 12 kilograms. Since we are rotating around the midpoint, we take 0.75 meters divided by 2, which would be 0.375, and square that. So our first I equals mr squared equation gives us 1.6875. 12 times 0.375 squared. Our second one is I equals m2r squared. 18 kilograms this time, 0.375 squared once again. That gives us 2.53125. Once you have both of these, to find the total moment of inertia, you simply add the two together. 1.6875 plus 2.53125 gives us 4.21875. All of our original numbers had two significant figures, causing us to round to 4.2 kilograms times meters squared. Now, to solve the second equation, to solve the second problem in number 2 here, we come over here. Created an equation basically for each one separately when we don't know the actual point of rotation. So I1 is equal to 12 kilograms times R1 squared. I2 is equal to 18 kilograms times R2 squared. Since R2 is going to be 0.75 minus R1, substitute that in and multiply it out, and I get 10.125 minus 27R1 plus 18R squared. I add this to the I1 equation, which was 12R1 squared, to give me a total, tell me that the total moment of inertia, it should not be I2 on the right side right there. That should just be I. So our total equation for I is 30R1 squared minus 27R1 plus 10.125. This gives us an equation for the moment of inertia. Now, in order to solve for the lowest moment of inertia we can solve, we recognize that this is a quadratic equation. And to solve for the low point, the minimum of a quadratic equation, we use the formula x equals negative b divided by 2a. Our equation is already set up in ax squared plus bx plus c form. So I have 30r1's 30 is my value for a, negative 27 is my value for b, and 10.125 is my value for c, although I do not need c in this case. Substituting in our values, we have negative 27 first, listed here first, because that's negative b. So I have negative 27, which would be obviously positive 27, divided by 2 times 30. 2 times 30 being 60. So negative 27 is 27 divided by 60, which gives me 0.45, which means that if it is rotated at a distance 0.45, this would be R1 in this case. So a distance 0.45 away from the 12 kilogram mass would be the correct answer.